7th graders, it's Mrs. Trombley. Today we are going to review how to add and subtract integers. First off, what are integers? They're positive or negative whole numbers, and even though 0 is not positive or negative, it's still included. So positive or negative whole numbers including 0, that's what integers are. The absolute value of an integer is going to help us as we're adding and subtracting, so you need to review the definition of absolute value as well. And the absolute value of an integer is the distance between the number and 0 on the number line. It's usually written inside these little parallel lines like that. So if I wanted to know what's the absolute value of any number n, we'd put it inside those little lines, and that means what's the absolute value of it. So you're just telling me how far away a number is from 0 on the number line. For example, this example 1 says find the absolute value of 2. So another way that might be written is like that. So how far away is 2 from 0? Here's 2, right? In order to get back to 0, it'd be 2 hops. So 2 is 2 away from 0. It's really that easy. I know, it's crazy. Example 2 says find the absolute value of negative 2. Well, here's negative 2. In order to get to 0, it took 2 hops, right? So the absolute value of negative 2 is also 2. Basically, the absolute value of a number that's written inside these brackets, the absolute value is always going to be positive because distances are always positive. I mean, think about that. If one of you lives a mile west of Jefferson Middle School and another one of you lives a mile east of Jefferson Middle School, would you say that one of you lives a negative mile away? No, that's craziness. You would say we both live a mile away. So same thing with absolute value. The absolute value of 2 and negative 2 both are 2 because they're both 2 away. Let's try a few. So the absolute value of 7, how far away from 0 is 7? 7. How far away from 0 is negative 5? 5. Now this one's a little bit trickier because do you see how this negative sign isn't written inside the brackets? That means I'm not taking the absolute value of this. This means I want the opposite of whatever the absolute value of 10 is. So how far away from 0 is 10? It's 10 away, and the opposite of 10, because it's on the outside, is negative 10. So we're not saying that the absolute value is negative 10. We're saying that the simplest form of this expression is negative 10, because that's not inside. This one here, just to kind of really understand the difference, I want the opposite of the absolute value of negative 10. Well, what's the absolute value of negative 10? It's 10. And the opposite of 10 is negative 10. So those would both be negative 10. Okay, hopefully that makes sense and it's just review. If it's not just review and you've never seen that before, let me know and we'll talk more about it in class, I promise. Alright, so knowing all of that, we're going to use that in a little bit to help us understand how to add integers with the same sign and add integers with different signs. And I ask you to use algebra blocks to find the sum. I'll model how to use the algebra blocks. I'm guessing you don't have any at your house. That's okay. I'll show you. You've seen this kind of mat probably in class. Hopefully we've discussed it a little bit. And we have a negative side of the mat and we have a positive side of the mat. And we have some little green blocks. These each represent 1. Okay? If I want a negative 1, I'm going to put it on the negative side of the mat. If I want a positive 1, I'll put it on the positive side of the mat. Alright, so example 1 says negative 4 plus negative 3. When you add, it means you're combining, right? So if I wanted to show negative 4 plus negative 3, this means that here's negative 4, here's negative 3, right? Add means combining them all together. So basically I'm just going to read this mat, and what do we have? We have 7. And they're on the negative side of the mat. So that means that negative 4 plus negative 3 is negative 7. Next example, we have a negative 2 plus a negative 5. Here's negative 2. I want to add negative 5 to that. And we look. Oh, look, it's kind of like a little smiley face. Okay, I'll stop being so distracted. Sorry. 1, 2, 3, 4, 5, 6, 7 on the negative side. So negative 2 plus negative 5 is negative 7. The last one, I have a negative 3 plus another negative 3. So that means I have 3 negatives and 3 more negatives. Adding means combine. Put them all together, you have negative 6. So basically, and yes, you're probably thinking, really? I just add them? Well, you just add them, and notice that, what do you notice about the sign? It stays the same. So if you're adding integers with the same sign, you add the digits and keep the sign. So the rule for adding integers with the same sign: add the digits and keep the sign. That goes for two positive numbers as well. If I gave you 4 plus 3, that's still 7. Nothing has changed about that, I promise. All right, now, sometimes you don't have the same sign, so we need to kind of give you some background knowledge in opposites. Two numbers that are the same distance from 0 but are on opposite sides of 0 are called opposites. A number's opposite is also referred to as its additive inverse. So instead of saying opposite, I could say additive inverse. So all of these examples are opposites. I have a 3 and a -3, a -2 and a 2, a -5 and a 5. Okay? If we're going to use the blocks to model this, it would look a little bit different because I have a 3 plus a -3. So here's +3, and to that I want to add a -3. Adding means we're combining all these things, right? The thing is, if you combine these, do you have 6 positives? Whoop, that one just jumped right over. Do you have 6 negatives? No. So we can't just add the digits here, can we? Because I don't have 6 of all one kind. A crazy thing happens, though, when you add opposites. They create 0 pairs. So when I go to combine all these together, if I combine this -1 with this +1, you get 0, right? They cancel out. Opposites, they don't attract, they cancel out. And those will cancel out. So what happens here when you add opposites is you end up with nothing, because opposites cancel each other out. They equal 0. All right, so an example. If I owed someone $50 and I paid them back $50, I now have 0 debt, right? Because a -50 and a +50, when put together, equal nothing. So a 3 plus a -3, that's 0. A -2 plus a +2, 0. A -5 plus a +5, 0. Always. So speaking of which, when you turn your page, there's a little fill in the blank here of this rule. It says the sum of an integer and its additive inverse or opposite will always be 0. This happens because a number and its opposite create 0 pairs with nothing remaining. So if you see the problem where the digits are the same but the signs are opposite, we know, oh, that's that additive inverse property. Those are opposites of each other. They cancel out. And we're going to use that to help us with this next set. So in these problems, I don't have the same exact digits, but we do have different signs. So now we want to figure out, how do we add integers with different signs? And we're going to use the blocks again. So I have a -2 plus 5. To model that on this mat, a -2 plus plus a +5 would look like this, right? Now addition means I want to put them all together. And when you go to put them all together, I don't have 7 of one kind. I can't just add up these blocks, right? But if I'm trying to combine these, I do know what happens if I combine this negative and that positive. They're gone. Poof, additive inverse, they are gone. And that negative and that positive will cancel out. And now I see I can't combine anything else together, right? Whatever's left is my answer. So I'm left with 3 blocks on the positive side. That means that a -2 plus 5 is a +3. Let's try another one. I have 4 plus -2. So that means 4 positives, 2 negatives. I don't have 6 of any one kind of block, do I? But I do have 0 pairs I can make. Those 2 negatives will cancel out those 2 positives. I can remove them, and we're left with a +2. Everything's just jumping all over the place on me this morning. It is morning where I'm at. It's about 8 o'clock on August 5th while I'm recording this. That's how I like to spend my summer. It's good times. All right, -6 plus 1. Here's -6. Here's +1. I can't say I have 7 of anything, but I can combine these still. I can combine this -1 and this +1. They make a 0 pair because they create 0 when you add them. And I'm left with 5 on the negative side of the mat. So take a look here. We want to come up with rules because I don't want, if I give you like -100 plus 75, I don't want you setting all these blocks out. So when you have two different signs, you see it's not the same as what we did before. You can't just add the digits, right? What are you actually doing with the digits? 2 and 5, we have 3. 4 and 2, you get 2. 6 and 1, you get 5, right? So we're just subtracting. When you have one of each, you're subtracting the digits. And when I say digits, I'm kind of talking about the absolute value, not thinking about the positive or negative sign. So to get this 3, I'm just going to do the higher one minus the lower one. 5 minus 2 is 3. And then to figure out what your sign is, it's always whatever you have more of. If you look at -6 plus 1 one more time, I know that when I make my 0 pairs, I'm going to have more negatives than positives, right? So whatever I have more of to start, that's the sign of my answer. Think about it. So we subtract our digits. 5 minus 2 is 3. And I have more positives. My answer is positive, because after you take away those 0 pairs, you're left with more positives. If you have +4 and -2, we subtract those digits because we're taking away 2 0 pairs. And you're going to be left with 2 positives because you have more positives than negatives. And here I have 2 different signs. 6 minus 1 is 5. So I'm taking the absolute value of that. I'm subtracting their absolute values, high minus low. 6 minus 1 is 5. I have more negatives than positives to start, so my answer is negative. So rules for 2 different signs when you're trying to add, you're going to subtract the digits. And I know it seems crazy that you are subtracting, even though it's an addition problem, but when you are adding, you're combining, and it just so happens when you combine a positive and a negative, they equal 0. So that's why it seems like you're taking away. So subtract the digits, take the sign of the greater digit. Take the sign of the greater digit. So whatever you have more of, that's what your sign is. Let's practice just a few here. -9 plus 2. First off, notice these are 2 different signs. That means I subtract. 9 minus 2 is 7. I have more negatives than positives, so my answer is negative. And picture that with the blocks. If you had 9 negatives and 2 positives, you'd be able to remove 2 0 pairs, right? You'd be taking 2 away from this side and 2 away from this side. You'd have 7 left on the negative side. Here I see I'm adding opposites, and we know that when you add opposites, you get 0. Here I have 2 of the same sign, so that means I have 11 negatives and 6 more negatives. That means that I now have 17 negatives. When you add 2 negatives, you add the digits normally and keep the sign, because they're all on the same side of the mat together. -10 plus 7, 2 different signs. Subtract the digits. 10 minus 7 is 3. I have more positives than negatives, so my answer is positive. With this one here, I get a lot of people that say 0. These aren't opposites. It's just the same exact number. If you have 7 negatives and 7 more negatives added to it, there aren't any 0 pairs. You now have 14 negatives. These are opposites. -1, +1, and when you add those, they will disappear. You're like a little magician with the additive inverse property. So that's basically the addition rules. Now we want to look at subtraction. And subtraction and addition have a lot in common, so you might be, maybe you need a break, you want to pause me for a minute, but this shouldn't take quite as long as the addition took. All right, I want to start off just showing you with a number line. I'm not trying to treat you like elementary students. It's just that this number line really helps things make sense. And I'll apply it to what we're going to do now. So if you have 8 minus 5, you learned in subtraction, moving on to subtraction now, that the number you start with is where you begin. So here's 8. If I want to take 5 away, that means I'm going to move 1, 2, 3, 4, 5 on my number line, right? So 8 minus 5, that's 3. On the opposite side here, if you have 5 minus 8, that 5 shows you where to start, right? And taking 8 away means I'm going to move to the left on the number line. So 1, 2, 3, 4, 5, 6, 7, 8. That's -3. It's not +3, is it? And the last one here, I have -6 minus 2. So -6 tells me where to start. And if I'm taking 2 away, here's my -6. 2 away means to the left. 1, 2. That would be -8. Okay, so there are some patterns here that we can use to help us. And it has to do with using our addition rules. I'm going to kind of jump right to the point here on what I would like you to do when you see subtraction problems. I'm going to feel kind of like an infomercial, but have you already learned those integer rules for addition? Yes. Wouldn't it make sense to be able to use them again? So what I would like for you to do is change all of your subtraction problems to addition problems, and then you use the rules you already know. And in order to change subtraction to addition, and I have these all set out on the next page for you, all you have to do is a method called keep, change, change. And you change the problem to an addition problem, but you're not changing the value of the answer. So let me show you how to use this, and then we'll kind of review it on the next page in a moment here. 8 minus 5 is 3. We know this. We learned this a long time ago. What you can do is we can also make this an addition problem that still has a solution of 3. And how you do that is you keep the first number the same. So keep the 8. We change our subtraction to addition. We change the sign of the number that follows the subtraction sign. And I usually, when a negative is being added, we wrap it up in parentheses so it doesn't look like plus minus, what's going on? I can see I'm adding a negative 5. We just learned that when you have opposite signs, you subtract the digits and take the sign of the greater digit, right? So do you see how 8 minus 5 and 8 plus negative 5 are really the same? They are. They are, I promise. So look at this next one. I'll show you that it works. We're going to do keep, change, change. Keep the 5, because in subtraction, you can never change what you start with. I'm going to change subtraction to addition, and that 8's now going to become a negative 8. Again, two different signs. Subtract the digits. 8 minus 5 is 3. I have more negatives than positives, so it's a negative answer. Last one here, negative 6 minus 2. When you keep, change, change, I end up changing negative 6 minus 2 into negative 6 plus negative 2. Those mean the same thing. And when you add with the same signs, don't you just add the digits and keep the sign? 6 plus 2 is 8, and it's negative. So all you're going to do for subtraction, you can turn your page now, is keep, change, change your problems, make them addition, and follow the rules that you already know. So for addition and subtraction, you really just have one set of rules. You only need to remember the addition rules. So again, the steps are kind of outlined for you here. You leave the number that you start with alone. Don't ever change the sign of it because you can't change what you start with. If I have a negative $100 balance in my bank account, I can't just erase that negative sign and make it a positive. I wish I could. That would be awesome. But you can't. You can't change what you start with. We change our subtraction sign to an addition sign, and whatever number follows the addition sign, you change the sign of it. Okay? So then we're just following our addition rules. I would like you to rewrite these as I am rewriting these. Don't just put down a bunch of answers. That's not going to help you. Alright, so the first one, I have 3 minus 12, common error. A lot of people want to tell me, oh, that's 9. Well, 12 minus 3 is 9, but 3 minus 12 isn't. 3 minus 12 means keep, change, change. So 3 minus 12 is really the same as 3 plus negative 12. I'll put those in parentheses. So that's two different signs. You learn that when there are two different signs and you are adding, because this is an addition problem now, you subtract the digits. 12 minus 3 is 9. You have more negatives than positives. My answer is negative. Next one, negative 8 minus negative 13. Keep, change, change. So keep the negative 8. Change subtraction to addition. Change negative 13 to positive 13. So it's not always going to be a negative number that follows. If the number that followed the subtraction sign was negative to start, it's now going to be positive. So negative 8 minus negative 13 is the same as negative 8 plus 13. They're going to give you the same solution. This one's just easier to deal with instead of having a numbered line to try to figure it out. So when you take 13 minus 8, because these are two different signs, we end up getting 5, right? And it's going to be a positive 5 because you have more more positives to start. 3 minus 3, now you might be thinking, I know 3 minus 3 is 0, right? Yeah, and just to prove this, if you keep, change, change, this would be your new problem, right? 3 minus 3 is the same as keep, change, change. And you learn when you add opposites, you do get 0. You'll probably end up changing problems like that because you just get so used to doing it. All right, keep going. Keep, change, change. So that was a positive 9, it's now a negative sign. When you change that to addition, you change the sign of that. I'm adding two negatives, that means I get to add the digits normally. So 14 plus 9 is 23, and a negative plus a negative is a negative. 0 minus negative 8 isn't negative 8. When you keep, change, change, 0 plus, that was a negative 8 that was being subtracted, right? Now that we're adding it, the sign changes. So 0 minus negative 8 is positive 8. All right, negative 12 minus negative 12. Now some of you look at this and you think, well, any number that you're subtracting from itself is 0. Just to prove it, keep, change, that was a negative 12, is now a positive 12. I'm adding opposites, right? That means 0. All right, we're down to the last two. Thank goodness. Whew. Okay, this one I put a couple numbers that were being subtracted so you can kind of see how this would work. When you keep, change, whatever the very first number in the problem is, that's what you're leaving alone. When you change subtraction to addition, whatever number follows that subtraction sign, you change the sign of. So we're just going to kind of change this from left to right. So it's 7 minus negative 12, so that's going to become plus a positive 12, right? And now I'm supposed to subtract 14, that's going to become plus negative 14. So you're just doing everything from left to right. Keep, and then we did change, 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 change. So keep, change, 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 change. Say that 10 times fast. I dare you. Okay, you can stop now. Moving on. You've learned about some properties, hopefully, called the associative property and the commutative property of addition that says you can add these numbers in whatever order you want to. You can, if you wanted to add the negative 7 and the negative 14 first and then add the 12, or add those together first, you can. So I'm going to use the associative property here, and I'm going to group these ones together first. You could go from left to right, it doesn't matter. But I just see a 12 and a negative 14, and I know that's going to leave me with a really low digit. I like that. I like to add lower digits. So a positive 12 plus a negative 14, that would be negative 2. Subtract the digits, sign of the greater. And I still have this negative 7 plus negative 2. When you add two negatives, you add normally, and you keep the sign. So that would be negative 9. If you went from left to right, you'd say negative 7 plus 12, that's 5. And 5 plus negative 14, oh, that's negative 9. So really, you can add it however you want. That's what's great about addition. Another great reason to keep, change these. All right, last one. I'm going to keep the 0 that I start with. Here's subtraction. When I change that to addition, I change the sign of the number that follows the subtraction sign. That was a positive 9. I'm going to make it a negative 9 now. Here's another subtraction sign. I'm going to change it to addition, and I have to change the sign of the digit that follows it. So that was a negative 5. It's now going to be a positive 5. And here I see this 0. That means nothing to me. Ha ha. I know. They're all cheesy jokes. I can't help it. So I'm going to use the associative property again and group those numbers together. When you add negative 9 plus 5, they're two different signs, so I'm going to subtract the digits. 9 minus 5 is 4. And I see I have more negatives than positives, so that makes my answer negative. All right, we'll do some more practice tomorrow. See you then.